Hi everyone, in this video I'm going to go through an activity using pandas. So to do this activity you can click into the pandas 1 reading and then scroll to the bottom and you can see that there is a Bridger snowfall.py file that we're going to add some functionality to. So to start off I'm just going to download this into my CSCI 127 folder and save it there. And then I'm going to open it with idle. And we can see at the top we have our import statements for pandas and matplotlib so we can plot and manipulate some data. And then there are just a few lines of code that are defining 3 lists for us. We have years, which gives us a list of 2010, 2011, 2012 through 2019. These are years that we're going to have some measurements about the snowfall at Bridger Bowl. Next, we have a list of total snowfall. So each of these is the total snowfall that year in inches. And finally, we have a list of largest snowfall, again in inches. So let's take a look at the activity and see what we are supposed to do here. So the first thing we're supposed to do is to create a data frame with 3 columns, year, total, and largest. And so in the video that you may have watched before this, we mostly were reading data in from a CSV, but as you can probably imagine, there are other ways to create data frames, including from these lists that we have right here. So what I'm going to do is I'm going to go over to the documentation for pandas. It says the pandas documentation is here. You could click this link. You could also just search pandas documentation and that will get you there. So if I'm in the pandas documentation, I know that I would like to create a data frame, right? So I'm just going to go ahead and search data frame here. And we can see, oh, pandas.dataframe, that is what we would like to create. And let's just see if there's an example of creating one not from a CSV. So here, this first entry is constructing data frame from a dictionary. And what is going on here? We're creating this dictionary here has as its keys the column names and as its values the column data. So we have column 1 and that has data 1 and 2. We have column 2 and that has data 3 and 4. And that's how we end up with this nice table right here where column 1 has 1, 2, column 2 has 3, 4. So what does that look like for us? Well, maybe we start off by creating a dictionary. What did our columns need to be named? Let's go back to the activity. Our columns are year, total, and largest. So we know that we're going to have a dictionary with the key year. We're going to have, and that will have some data. We'll have the key total. That will have some data, and we'll have the key largest. That will have some data. And now what data should each of these have? Well, year should have the years list as its data. Total should have total snowfall as its data. And largest should have largest snowfall as its data. Now, to create our data frame, maybe we'll call it df, we just need to say pd.dataframe, as we see in the documentation, pd.dataframe. Then we can just pass in our dictionary that we created. And I believe we can actually just do that without specifying which parameter it is. So let's print snow data frame is, and then we'll print the data frame. So let's see what happens when we run this. And it looks like we are indeed getting what we hoped. So we see that the year column has 2010 to 2019. Total looks like it has the total snowfall. Largest has the largest snowfall. So maybe I will put a comment here, create a data frame using a dictionary with column names as keys and column data as values. Okay, so I believe we have satisfied that first bullet point. Now we need to write the data frame to a CSV using the toCSV method. So this is something, if we wanted to know more about this, we could look up. This is the documentation for the data frame object, and so it should have a toCSV method. And here we see it does indeed. Let's click on it and take a look. Okay, Pandas. So the data frame object has a toCSV method. It has a lot of optional parameters, but most importantly, the path or the file name. And so let's just go ahead and do that. Now we're going to write df to a file using toCSV method of data frame object. So how do we call this method? We just say df, and then we use the dot notation to call the method toCSV, and we need to pass in a file name. Maybe we make that a variable, so that, just to be more clear, and maybe we call it Bridger Snow Data.csv. And now all we need to do is put in that file name into our call df.toCSV. So let's go ahead and run this. And maybe I'll also just put a print statement here. Saved data to file Bridger Snow Data.csv. So then we just get a little message to ourselves saying that we saved this. And I'm going to add a new line before. Just seems nicer to me. And now, just to make sure that we did indeed write this file, let's go ahead and try to open up that file in, maybe let's just say text edit. We'll see if we can find text edit, applications. There we go. And now we're gonna open what will we open? We will open, that's not the right folder, this one. So we should have written bridgersnowdata.csv, and it looks like we have. And let's take a look at it. And so let's make this bigger. One thing that, as you look at this, you might notice is that there's this extra column here, the 0, 1, 2, 3, etc. column. And we also see that in when we print out the data frame. And what's going on here is that this is the index of the data frame, and Pandas data frames are very powerful. You can customize them a lot, and one thing that you can do is actually assign your own index here. We will not be worrying about that in this class, but if you are confused about what these numbers are, though, that is the index. And so if we actually don't want the index in there, what we can say is, when we call the toCSV method, we can say index equals false. And this is going to tell Python to, when this is written, do not put the index in. So let's run this. And then let's go back to our text program. Let's see if we can find it. Oh, I seem to not be able to use my Spotlight search for some reason. But we can still open text edit another way. And now I'm going to open up Bridger Snow data, and we should now, because we said index equals false, we now have no index in this file. So that's just something that might be useful to you if you're using Pandas for another project, but you won't need to do it in this class. Deal with the index. All right, let's take a look at what we need to do next. So now we would like to print the shape of the data frame. So let's go ahead and do that. Maybe I'll add another comment here. Index save to CSV without index. Okay, now we just want to print the shape of the data frame. And I'm actually going to do this maybe sort of more descriptively than we could just say something like print what? df.shape, and that will print the shape. So let's go ahead and do that. And maybe I will add some line breaks and say, yeah, I'm just going to add a line break. I'll run this. But I'm actually going to say the data frame has this placeholder rows and this placeholder columns, using the .format method of strings, which allows me to write these placeholders, and then whatever I pass into format first, which is going to be df.shape at 0. If we take a look at my output here, what will what will df.shape at 0 be? It will be 10, and that makes sense. Oh, I'll move this out of the way. And what will how do I get the columns? Well, it's just df.shape at 1. So now I'm going to print this, I would say, more descriptive method about the shape. The data frame has 10 rows and 3 columns. All right, what is our next task? Create a second data frame, big snow years, which includes only years with at least 250 inches of snow. So we need to create a data frame with only entries, only years with at least 250 inches of snow. So we are supposed to call this big snow years. And what is it supposed to be? It's supposed to be those rows of data frame df where there were at least 250 inches of snow. So the way that we learn to do this, it's using a process called masking, but the basic idea is that we should write a conditional inside these brackets here where we get true whenever whenever the amount of snow was at least 250 inches. And what is that? That is the data frame at total. That is our total is our total snowfall column. So this is the total snowfall column, and at least 250 inches. So this is saying for all values in the total column, check whether they have at least 250. There are at least 250. And then if I just close that bracket, I will now have a new data frame, and I will go ahead and print it out. I'm going to say print big snow years data frame is, and now I will print my data frame, which was called big snow years. And now I'll save that and I'll run it, and let's see what happens. And we can check our work here. It says big snow years data frame is. We've got years 2010, 2011, 12, 13, 14, and 17. And these do look like they all had at least 250 inches of snow. So that's good. And then let's check back and see if there's anything else. Create a bar chart showing total snowfall per year. All right, let's go ahead and work on that. Create a bar chart showing total snowfall per year. Total snowfall per year. So, what are we going to need to do here? Well, we're going to need to pass in year data and total snowfall data to matplotlib. So if you remember from the matplotlib lab, we used the bar function from within the PLT, our PLT alias here. So I'm going to say PLT dot bar, and now I need to pass in my x's, which are going to be my years. So what is that? That's just data frame at year. That's my x. Maybe I'll write this. PLT dot bar of x values, y values, and then any extra parameters that we want to put in. But let's just start with x values and y values. What are the y values? We said that they should be total snowfall. So let's go ahead and just, for now, let's just see what this looks like. Oh, and to actually show it, I'm going to need to call plt.show. Or I could save it using savefig. All right, so it looks like we have our plot here. Does it seem right? Well, it goes 2010 to 2018, and it looks like we are indeed plotting the total snowfall. For example, 2012 had 388, so that is looking good. And if we wanted to make this a little nicer, we would do something like maybe plt.title, and we would pass in a title, maybe snowfall Bridger Bowl yearly snowfall. We could do something like set the X label to be year and the Y label to be snowfall in inches. And then we could run this and see what that looks like. We've got a title, snowfall in inches, and year. And to me, that looks pretty good. So I'm going to say that we have successfully completed Activity 1. Thanks, everybody.